Alright, so welcome to our tutorial session. Today we are looking at question number 3 for 2022 test 2, Pharmaceutical Chemistry. The question reads, a basic solution of compound X exhibit a maximum absorption at 2750 nanometer. We are given the concentration to be 2.35 times 10 to the power negative 6 molar of compound X, which is having a percentage transmittance of 51.2% of incident radiation at this wavelength. They had written 270, but it was supposed to be 2750 nanometer. So they are saying when this concentration is placed in a 1 centimeter cell. So the first question reads, what is the absorption of the solution? So when we are given a compound of a given concentration, and when this compound of a given concentration is subjected to a radiation at a specific wavelength as we are given here, if we are told to calculate the absorbance or the absorption of the solution of a given diameter, there are two ways in which we can calculate the absorption. So the first way, we say absorption is equal to log 1 over transmittance. This is the first way in which we can calculate absorption. The second way, we can say absorption is equal to in fact, we are not going to use this second way due to the reasons. We will discuss this method later because of what we are given. So when we are using the formula, we look at what we are given. So in this case, we are given the transmittance. So once we are given the transmittance, meaning we have to use transmittance. So the formula which has the transmittance is the one which we have here. So this is the formula which has a transmittance. So what we are going to do, we are going to say, we are going to convert this transmittance, the percentage transmittance we are given, into a decimal. So we are given 51.2%. So to convert this into a decimal, we will divide this by 100%. This is going to give us 0.512. So this is the transmittance which we have. So replacing this in our formula, we are going to have absorption is equal to log 1 over 0.512. So those with calculators can follow. What is, first of all, let's find the 1 divided by 0.512. Here we get we get 3 absorption is equal to log 1.953125. So when we punch the log of this answer here, we get 0.2907 30039. So that's what we get. That's what we get. So that's what we get. Okay, so finally, for this one, absorption is going to be, we can round off this to 0.291. This is our absorption. It's a ratio, so it doesn't have units. So this is what we are going to have as our absorption. So colleagues, we have handled the first question. We have handled the first question where we are calculating absorption. So now let's go to the second question. Let's go to the second question. Let me just erase this. We go to the second question, which reads, what is the molar absorption at 2750 nanometer? Okay, so remember we said the absorption can be given by the formula log 1 over transmittance. This is not the only formula which we can use to calculate absorption. This absorption can also be given by the formula absorption is equal to concentration multiplied by the molar absorptivity at a specific wavelength, this is lambda, multiplied by the diameter of the cell. So this is another formula which we can calculate the absorption. So making the molar absorptivity the subject of formula, we are going to have molar absorptivity at a specific wavelength is equal to absorption divided by the concentration multiplied by the diameter of the cell. So this is the formula we are going to use to calculate the molar absorptivity. We know that absorption is a ratio, it doesn't have the units. Concentration is given in molar, which can also be mole per liter, and our diameter is given in centimeters. So let's just replace, since we have all the values now. So our absorption is, we have already calculated it, is it was initially 0.290730039 before we rounded it off. Then if we divide this by our concentration, which is 2.35 times 10 to the power negative 6, multiplied by our concentration, which is our concentration is 1 cent. Sorry, this was molar, and then our diameter is 1.00 centimeters. So this is going to give us 123,714.9102. Those with calculators can confirm. Those with calculators can confirm. Let me just lab the first part. Okay, so this is what we have. Let me just bring it here. On top. So we have 1, 2, 3. 1, 2, 3. 1, 2, 3, 7, 14.9102. So this is per molar per centimeter. These are the units. These are the units. Since the numerator, which was absorption, didn't have any units, so these are the units, because we have gotten the units of the diameters. I mean the centimeter from the diameter and the molar from the concentration, and they were all this. I mean the yeah. So the next thing we are going to do here is we can put this answer in we can put it in scientific notation. So if we are to put this in scientific notation, we round off. This is going to have 1, 2, 3, 4, 5. So we are going to have 1.24 multiplied by 10 to the power 4 per molar per centimeter. So this is our molar absorptivity. Okay, let me just write this properly. Okay, so this is 1.24. We have rounded it off, collect to 3 significant figures. We have rounded it off, collect to 2 significant figures. So it's to the power 5, in fact, to the power 5. So to the power 5. So this is our final answer. Then lastly, which is part C of the question, it says what would be the percentage transmittance if the cell length were 2.60 centimeters? So how can we calculate the cell length of this? How can we calculate the cell, I mean the new transmittance if the cell length? Remember we have said that absorption can be given by 2 formulas. The first formula we had used, we said absorption can be given by log 1 over transmittance, and we also said absorption can be given by concentration, molar absorptivity multiplied by the transmittance, I mean the diameter of the cell. So equating these 2 formulas, we are going to have log 1 over transmittance is equal to concentration, molar absorptivity at a specific wavelength multiplied by the diameter. So we already have the molar absorptivity, we know the concentration. Now we are going to replace diameter, I mean our diameter with the 2.60 centimeter, our new diameter, and then we try to calculate the transmitter. So this is going to be log 1 over transmittance is equal to our concentration, remember, was 2.35 times 10 to the power negative 6 molar multiplied by our molar absorptivity. We have found it was 1.23. It was 1.224 in fact. Let me just erase this. Okay, so we had initially 1.237. Okay, let me just write it like this, times 10 to the power 5, then multiplied by our new diameter is 2.60 centimeters. So when we multiply this, those with calculator can try to multiply. When we multiply this, we are going to have Okay, 0.755898101. So this is what we're going to have. So the concentration, this value here, it is not going to have, let's see where the units have gone. So the concentration was in molar, then the concentration was in molar, and we are multiplying it by the diameter, the molar absorptivity, which was in. So the thing is that, remember that our molar absorptivity had the units of per molar per centimeter. So those units have cancelled each other. This value doesn't have units. This value doesn't have units. So to get our log cancelled, we are going to multiply it by the inverse log both sides. We are going to multiply by inverse log both sides. By this side, we are going to multiply it by log inverse, and even this side we are going to multiply it by log inverse. So let me just erase on top here because of space. Let me just erase on top here. We multiply by log inverse both sides. Those who are good in mathematics can even use bases, say base 10, but we still get the same values here. So what we are going to have here, when we multiply log with a log inverse, we are just going to have 1 over transmitters, the log has gone, is equal to, when we get the inverse log of this one, okay, so after multiplying this value with the inverse log, so on the calculator you punch shift log, then you put this answer here, you get the inverse log. You are going to get the inverse log of this value is 5.700305097. That's what we are going to get. So what do we do with this value? You are going to make T the substitute formula. So to make T the substitute formula, what you are going to do is we are going to say transmittance T is equal to, you get 1 divided by this answer here, which is 5.700305093. So our transmittance is going to be we get 0.175429206. This is what we are going to get. So after getting this, the last thing which we are going to do is we are going to, what we want is a percentage transmittance. What we want is the percentage transmittance. So we multiply this by 100%, we get 17.5429206%, which is approximately 17.5%. So this is the final answer which we are going to get. Thank you so much for listening to this tutorial. Bye bye.